Hey guys, this is Bharani from Great Learning. So you guys would have come across the term Python programming and must be wondering what exactly is it and why is it so popular? Well, to answer that, let's just say Python is used to perform a lot of cool stuff. So using Python, you can do web development, machine learning, game development, computer vision, and a lot of other cool stuff. So understanding the importance of Python, we have come up with this comprehensive tutorial on Python. And this tutorial has been curated in such a way that even if you don't have any prior coding knowledge, you can just start off with this tutorial and gain complete expertise at the end of it. Now, I'd also like to tell you that we'll be coming up with a series of high quality tutorials on artificial intelligence, machine learning, and computer vision. So please do subscribe to Great Learning's YouTube channel and click on the bell icon so that you get a notification of our upcoming videos. And also, if you have any doubts or queries, please do comment below. We'd love to help you out. So let's have a quick glance at the agenda. So we'll start by installing Python and the required Python IDEs. So that'll be our first task. And then we'll go through some of the Python basics. So that'll be variables, data types, and operators. After that, we'll look at some of the common data structures in Python. So we'll go through list, dictionary, tuple, and sets. And then we'll work with user-defined functions in Python, following which we'll work with how to implement object-oriented programming in Python. After that, we'll work with NumPy, using which we'll be implementing numerical computing. And then we'll see how to implement data manipulation with the Pandas library. And then finally, we'll see how to do data visualization with the Matplotlib library. So let's start by installing Python. And we can install Python from this website over here, www.python.org. So I'll click on this. Right, so you see that you have the latest version of Python over here, Python 3.8.0, and you can download the Python version with respect to whatever operating system you're using. So if you have a Windows system, then you can download Python for Windows. If you have a Linux or Unix system, then you can download Python for Linux or Unix. And if you have a Mac operating system, then you can download Python for Mac operating system. And since I have a Windows system, I'll download it for Windows. So I'll just click on this over here and you see that the download has started. Right, so now I actually have Python installed in my system. So once the installation of Python is done, we need something known as an IDE. So IDE basically stands for Integrated Development Environment. And Integrated Development Environment basically makes your work much easier while programming. So it gives you certain prompts and you have all of the tools present in the IDE. And one such IDE, which is very famous for Python, is Pycharm. So we can install Pycharm from the site over here, jetbrains.com/Pycharm. So let's just wait till the site opens up. Right, so you have the download button over here. You just click on this. And for our programming purpose, we'll just download this community version over here, right? So for pure Python development, you click on download and the download would start. And again, since I'm using a Windows system, so this is for the Windows system over here. All right. Now, Anaconda is a Python distribution, which basically provides you all of the packages inbuilt. So you have packages such as Matplotlib for visualization, Pandas for data manipulation, and NumPy for numerical computing. So you don't have to manually install all of these packages. So when you actually install Anaconda, all of these packages are actually pre-installed in Anaconda. And for doing all of your coding, you have something known as the Jupyter Notebook. So first to use a Jupyter Notebook, we would need Anaconda. So let's go ahead and install Anaconda. Right, so this is anaconda.com and I'll just click on download now. So we need the Anaconda distribution. And again, I'll click on download, right? So we've got Windows, Mac OS, and Linux. And this is the latest version of Python 3.7. So that is what we had downloaded earlier. So this was the older version of Python 2.7, but everyone has moved on to Python 3.7 now. And that is why we'll also be downloading Anaconda for the latest Python version, which is Python 3.7. So we'll automatically start the download for 64-bit operating system. So once the download for Anaconda is done, we need something known as the Jupyter Notebook, which I've already told you. So as it is written over here, Jupyter Notebook is basically a browser-based interpreter that allows us to interactively work with Python. And this is how your Jupyter Notebook looks like. So let me go ahead and open up Jupyter Notebook. Right, so let me open up Anaconda prompt first. So I'll type in Anaconda prompt. So this is the command line interface. Now to open up Jupyter Notebook, I'll just type in Jupyter space notebook and let me wait till this opens up. Alright, so this is the Jupyter Notebook over here, right? And this is how it looks like. Now to open up a new notebook, we just have to click on new and we'll click this new Python 3 notebook. And we have successfully opened our new Python notebook. Let me just rename this to Python programming. Now, once this is done, let's go ahead and write our first Python program. So we'll just use the print statement. So you just have to type in print, and inside this, I'll type in, let's say, this is Sparta. And all you have to do is click on run, and you have your first program ready. You have successfully printed this Sparta on the console. Well, you've just taken the first step to hacking NASA, right? So you just have to take the baby steps and you'll be an expert at Python programming, and you have successfully started with your first Python program. All right. So now that we have written our first Python program, the question which needs to arise in your mind is, every programming language needs to deal with a lot of data. So where do we actually store this data? Well, this is where variables come in. So let's say you have to store the names of all of the students present in a classroom. So let's say the names are John, Sam, Matt, Bob, Anne, Julia, and so on. And you have 50 such names. And you have to store all of these names somewhere. So how do you do it? Well, all you have to do is take a variable and store all of these names in a variable. Now, you must be thinking, what exactly is a variable? So let's understand that with this example. So simply put, variables are basically temporary storage spaces where you can store data or values. Now, let's take this example over here. So consider this folder to be a variable. So what you do is you store this value temporarily inside this folder. So this value is John, which is the name of the student. So you've taken this value and place inside this variable for a certain amount of time. Now after that, since this is only a temporary storage space, you can take out this variable and replace it with Sam, right? So now this variable holds the value Sam. And after some time, again, you decide that Sam is not the name which I want to store, and I want to store the name Matt. So again, you take out the name Sam and store Matt inside this folder. So this is how variables work. They are temporary storage values where you can keep on changing the values inside it. So now that we know what exactly are variables, let's go to Jupyter Notebook and work with variables. So again, I'll open up a new Python 3 notebook over here. So now to assign a variable, I'll just create a new object over here and I'll name it as var1. I'll use the assignment operator and I'll give in the name. So the first name would be Bob, and to print it out, I'll just type in var1 over here again. Right, so we have successfully stored the value Bob inside var1. Now I'll change the value inside this variable. So what I'll do is I will actually store the value Sam inside this var1, and let me print it out again. So now var1 stores Sam. So initially var1 had the value Bob, and after some time I had replaced the value with Sam. Now again, let me change the value. So inside var1 I will be storing Matt, and let me print it out again. So this time it has the value Matt. So as you see, variables are just temporary storage spaces where the values can be changed. Now every variable is actually associated with a data type. So there are different types of data which a variable can hold. It can be of integer type, it can be floating or decimal type, it can be a boolean, it can be a string. So when it comes to integers, so you basically have numbers such as 10, 500, 1000, -10, -27, and so on. And floating are basically decimal point numbers, so 3.14, 15.97, or -2.1678. So any such decimal point number would be a floating point number. And then you've got Boolean values, or basically logical values, and true and false are basically your Boolean values. And then you finally have the string values. So a string is basically a set of characters enclosed together, right? So Sam is basically a set of characters, it is a string. And then you have Matt, which is basically a set of characters, it is a string. And strings are generally enclosed within double quotes, single quotes, or triple quotes. Right, now let's assign some different types of data to our variables. So let me create a new variable A, and I'll store the value 10 inside this. Now I'll go ahead and check the type of this. So the type of this variable would be int. Now inside A, I'll actually store a decimal point number. So this time I'll store 13.4, and then let me check the type of it. So type of A, again I'll click on run. So this time we see that there's a floating point number. So what you can basically notice is the type of the variable would depend on the type of the data which you are actually storing inside the variable. So if you store an integer type data inside the variable, then the type of the variable would be integer. And if you store a floating point or a decimal type data inside the variable, then the type of the variable would be floating type. Now similarly, let me go ahead and store a Boolean value inside this. So I'll store true inside this. Let me check type of A. So the type of A is bool. Now let me store a character value. So I'll type hello world. Let me remove out this W over here. And then again, I'll check the type of this. So type of A. And then the type of A is string. So finally, we have one more type of data, which is basically complex number. So complex numbers, you basically know that it has a real part and an imaginary part. So let me just type it out. So 4 plus, let's say 8j. Now, normally in mathematics, it is actually represented as 4 plus 8i. Now, when it comes to Python programming, we represent the imaginary part with j. So 4 is the real part over here and 8j is the imaginary part over here. So just to confirm it, I'll again check the type. So type of A. The type of A is complex. So all of these are the different types of data which we can work with in Python. So going ahead, we'll work with operators in Python. So we've got arithmetic operators, relational operators, and logical operators. So let's start off with arithmetic operators. I'll head on to Jupyter Notebook over here, and arithmetic operators are basically the normal mathematical operations which you do. So that would be addition, subtraction, and then you've got division, and then you've got multiplication. So these are the different symbols which you'll be using to perform these operations. So we'll start off with addition. So let me just add in a comment. So to add in a comment, you will use this hash, and then you'll type in whatever you want to add. So comments are basically statements which are not executed by the Python interpreter. And these are only to help the coder or the learner. Right. So I'll execute this cell over here. So I'll have one variable and I'll store 10 inside this, and I'll have another variable B. I'll store 20 inside this. I'll click on run. All right. So I'll start with addition operation. So I'll just type in A plus B and you get the value of 30. Well, this is quite simple. So this is the basic addition operation which you've been doing since your kindergarten, right? And also we'll be doing some similar operations. And then I'll go ahead and perform A minus B. So what do you think is the answer? Well, it's minus 10, because when you subtract 20 from 10, you'll get a value of minus 10. Now let's also multiply these two numbers. So I'll just type in A cross B. So that would be 10 into 20, which will give you 200. And then finally, I'll just type in A divided by B. So you'll get a value of 0.5. So 10 by 20 gives you a value of 0.5. So these were the basic arithmetic operations. Now we'll go ahead and work with some relational operators. So I'll just type in relational operators over here. So again, I'm putting down a comment. So relational operators. And relational operators basically help you to understand the relation between two variables. Now, what do I mean when I say it helps us to understand the relationship between two variables? So let's say when you have two variables, the value in one variable could either be greater than the value in the second variable, or it could be less than the value in the second variable, or it could be equal, or there might be no relation at all between these two variables. So this is where we'll have relational operators to find out what is the exact relation between two operands, right? So again, I'll just type in A equals 10 and B equals 20 over here. I'll click on run. Right, so I'll start with the less than operator. So I'll type in A less than B. So over here, I'm just checking if the value of A is actually less than the value of B. So we get a value of true. This means that 10 is actually less than 20. Now let me check if A is greater than B. Now we get a false value because 10 is not greater than 20. Now I have the double equal to operator. So with the help of the double equal to operator, we check if both of these values are equal to each other. Again, we get a false value because 10 is not equal to 20. Now there is the not equal to operator. So A is not equal to B. So A, I'll give in this exclamation mark, and then I'll give in this equal to symbol, and then I'll give the second operand, which is B. So we see that A is obviously not equal to B, or in other terms, 10 is not equal to 20. So these were some basic relational operators. And then we'll go ahead and work with the logical operators. So I'll type in logical operators over here. So the two basic logical operators are AND, OR. And this is how you represent the AND operator, and this is how you represent the OR operator. Now we'll actually start with the AND operator. Now, AND operator is used to check the condition or the logic between two variables. And this is how the AND operator works. So if both of the operands are true, only then the final result will evaluate to true. And if either of the operands is false or both of the operands is false, then the final result will be false. So I'll just create two variables over here, and this time I'll be storing the value true inside A, and I'll be storing false inside B. So I'll just execute this over here. All right, so now I'll type in A and B. So we are basically checking true and false. So what do you think will be the result? We get a false value because we need two trues, and only when we have two trues, that is when we'll get the true value. Now we'll check B and A. So when it comes to B and A, we are basically changing the position of these operands. That's it. So now it becomes false and true, and the answer is false. Now let me check A and A. So this will be true and true. So when you compare true and true, you get a true value. And finally, let me check B and B. You get a false value. So this is how the AND operator works. Now let's go ahead and work with the OR operator. So when it comes to the OR operator, if either of the operands is true or both of the operands are true, then you get a true value. And only when both of the operands are false, that is when you'll have a false value. So this time I'll type in A or B. This would mean true or false, and obviously we have a true value over here. Then I'll type in B or A. So this would mean false or true, and we obviously have a true value. Now let me go ahead and check A or A. So this would mean true or true. So when you have two trues, obviously it's a true value. And then finally, let me check B or B. And we have a false. So this is the only condition where you'll get a false value when it comes to OR. Right, so those were the basic operators in Python. Now let's head on to Python strings. So Python strings are the most widely used data types when it comes to Python. And as I've already told you, strings are basically sequence of characters which are enclosed within single quotes, double quotes, or triple quotes. And triple quotes are used to denote multi-line strings. So as you see this example over here, I am going to France tomorrow. So you have triple quotes around the string because this is present in multiple lines. So hello world is present in single quotes. This is a string. This is Sparta is present in double quotes. And again, this is a string. But when it comes to I am going to France tomorrow, this is a multi-line string. So that's the basic premise for strings. So now let's go to Jupyter Notebook and work with these strings. Alright, so I'll create a new variable over here and I'll store a string inside this. So I'll put in the string Joey doesn't share pizza. I'll click on run. Alright, so obviously no one likes to share their pizza, do we? Right? So now let's go ahead and work with the string. So let's say I'd want to extract the first character, which is J, from this entire string. Now when it comes to Python, the indexing starts from 0. So J is basically present at index number 0. So if I want to extract J, I'll type in A1, I'll put in square braces, and then I'll type in 0. And I have successfully extracted the first letter. And similarly, if I want to extract the last character from this entire string, so for that, you'd have to put in -1. And when I click on run, you get the value A. So this is how you extract the last character from the entire string. Now let's say I want to extract a sequence of characters. So I'd want to extract this entire word, which is doesn't. So 0, 1, 2, 3, 4, 5. So the index starts at 5 and it will go on to 6, 7, 8, 9, 10, 11, and 12. So let me type in 12 over here. I'll click on run, right? Now over here, I've given 12 because when it comes to the second term over here, it is exclusive. So 5 is inclusive, 12 is exclusive. So 0, 1, 2, 3, 4, 5. D is present at index number 5. Then 6, 7, 8, 9, 10, and 11. So T is present at index number 11. But if you only given 11 over here, then you'll get dozen, right? So what you have to keep in mind is when it comes to the second indexing term, it is exclusive. So that is why you'd have to go in till 12 and you'll get the entire word, which is doesn't. Now let's see how can we check the length of a string. So to check the length of a string, we have this length function, So inside len, I'll just pass in this variable, which is a1. And we see that the length of the string is 24 characters. Now, when you say 24, so this would include all of the spaces and all of the apostrophes and full stops and all of those characters as well. All right. Now, let's go ahead and work with some of the inbuilt functions of strings. So if I want to convert all of these characters into uppercase, so I'll just have to type in A1 and then I have this function upper. So I'll click on run, right? So I have successfully converted all of these characters to capital. Now, similarly, if I want to change all of these to small case, so I'll type in A1 dot lower. So everything is turned to lowercase. Now, similarly, if I want title case, so I'll type in A1 dot title. Right, so I have successfully changed all of these words to title case. So J is capital, D is capital. So over here, since apostrophe is taken as another character, that is why T is also given capital. And then we have S as capital and P as capital. Right, so these were some basic functions when it came to strings. Now let's go ahead and work with some non-primitive data structures in Python. So the main non-primitive data structures in Python are tuple, list, dictionary, and set. So when it comes to all of these data structures, so you can store multiple elements inside one data structure. So till now we've worked with only variables, and when it came to variables, we could store only one value in one variable. Now let's say if you go to a music concert and you'd have to store the names of all the people attending the music concert, and the strength of the audience would be around 10,000. So to store the names, you would require 10,000 variables. Now that's a lot of variables, and you'd have to manually store all of these names inside 10,000 variables. So that's a humongous task, and that's a tiresome task. So this is where you would need these data structures, where you can store multiple elements inside one single data structure. So we'll start off with the first data structure, which is basically tuple. So when it comes to tuple, it is an ordered collection of elements enclosed within round braces. So we have Curious JSON over here, and he'll be coming in between to give us some pointers. So Curious JSON tells us that tuples are immutable. Now, what does he mean when he states that tuples are immutable? So basically, when you go ahead and create a tuple, so let's say you add 5 elements inside one tuple. Now, you can't change or modify the tuple which you have created. So that would basically mean that, let's say if you have 5 elements, then you can't change the value of the second element or the third element, or you can't add another element inside the tuple which you have already created. So this is basically the immutability nature of tuples. And this is how you can create a tuple. So you will use these round braces over here, and inside these you will given the values, right? So as you see, tuple is actually a heterogeneous data structure. So over here you are storing a numerical value, a character value, and a Boolean value. Right, so let's go to Jupyter Notebook and work with tuples. So let me create a tuple. So I'll name the tuple as tup1, and I'll give in the values. Right, so this is our tuple tup1. Let's see how can we access individual elements from this tuple. So accessing elements from tuple is the same as accessing elements from a string. So all you do is, given the name of the tuple, which is tup1, you given this square braces, and then if you want to extract the first element, which is basically present at index 0, you will type in 0 over here, and you have extracted the first element, which is 1. Similarly, if you want to extract the last element, you have to type in -1, and you have extracted the last element, which is 23. And if you want to extract a sequence of elements, so let's say I want A, true, and B. So this would be from index number 1 going on till index number 4, because we'd want 1, 2, and 3. So I'll type in 1, 4, right? So I've extracted A, true, and B, right? So this is how you can extract individual elements from a tuple. Now, as I've told you, a tuple is immutable. So let me go ahead and try to change the value which is present inside a tuple. So I'll type in tup1, and let me change the value which is present at 0th index. And I'll change it to, let's say, 100. And we get an error over here. So the error is tuple object does not support item assignment. And that is because tuples are immutable. Now let me try to add a new value inside this. So we've got 1, 2, 3, 4, 5. So that would mean this is index number 4. So let me try to add something at index number 5. I'll type in Harry Potter. Again, we get the same error. So tuple object does not support item assignment because it is immutable. Now we'll head on to the next data structure, which is a list. So lists and tuples are quite similar. The only difference is lists are mutable while tuples are immutable. Now, what do I mean when I say lists are mutable? So this means that lists can be changed once they are created. So if there are 5 elements in a list, so the second element or the third element can be modified. And again, since I've said that there are 5 elements, so another 5 elements can be added inside this list. So this is the basic difference between lists and tuples. And this is how you can create a list. So you'll basically given square braces and you'll given all of the values inside the square braces. So let's head on to Jupyter Notebook and work with lists. So I'll type in L1 and I'll give in some values over here. And then I'll print it out. Right, so this is a list over here. And accessing elements from the list is same as tuple. So if I want to access the first element, I'll type in L1, I'll give in square braces, and then I'll give in 0. So I have extracted the first element. Now let's go ahead and access a sequence of elements. So I want to access these 3 elements over here, true, 2, and b. So this is index number 2, and then going on till index number 5. So L1 and 2 colon 5. Right, so true, 2, and b. So we have successfully extracted these 3 sequence of elements. Now let me go ahead and actually change the values inside this list. So I'll change this value 1 to 100. So I'll type in L1 0 and I'll assign the value of 100. Now let me print out L1. So as you see, initially the value of this element was 1 and then we have changed the value to 100. Now let's say I want to add a couple more elements inside this list. So I'll type in L1.append and I'll add an element and name it to be, let's say, sword. And then let me print out L1. Right, so I've successfully added a new element. So now I can actually add a list inside a list. So let me again use the append function over here. And then I'll add a list inside this. So I'll type in 1, 2, 3, 4, and 5. So let me again look at L1. Right, so I successfully added this new list inside this list. Now we can also go ahead and remove these elements. So to remove the last element, we've got the pop function. So I'll type in L1.pop. So as we see, this last element has been popped out. Now again, let me type in L1.pop and let's see what will be popped out. Right, so this time this element sword has been popped out. Now let me have a look at the modified list, right? So we are only left with these values because sword and this list has been popped out. So this is how we can work with lists. Now let's head on to the next data structure, which is a dictionary. So dictionary is actually quite different than a list and a tuple because it consists of key value pairs. And these are actually unordered collection of key value pairs which are enclosed within curly braces. And again, dictionaries are mutable. So this is how you can create a dictionary. So you'll put in curly braces over here. So first you'll put in the key. So over here the key is apple and then you'll give in a colon and then you'll give in the value. So for the key apple, the value is 10. And then you'll give in the next key value pair. So after comma, the next key value pair is orange 20. So orange is the key and 20 is the value. So let's go ahead and create our own dictionary. So let me create the dictionary over here. I'll type in D1. And then I'll give in these curly braces over here. So I'll just give in some names of fruits. So let's say the first key is mango and the price of the fruit would be the value. So mango costs 45 bucks. And then we've got apple. So let's say apples cost us 30. And then we've got orange and then orange costs around 77. After that, we've got guava. And then this would cost around 125. Now let me print it out. So this is our dictionary. Now what we have is key value pairs. So if I want to access only the keys, then we have the keys function. So I'll type in d1.keys. So I'll give in the name of the dictionary and then I'll follow it up with the keys function. d1.keys, right? So I have extracted all of the keys, which are mango, apple, orange, and guava. Similarly, if I want to extract all of the values, which are basically the price of all of these fruits, I'll type in d1.values and I have extracted the prices of all of these fruits. Now, let's go ahead and modify some of these elements. So I want to change the cost of mango. So I'll type in d1 and then I'll give in the name of key. So the name of the key is mango and the cost would be 100. And then I'll type in d1. So initially the cost of mango was 45 and then I've altered it to be 100. So this is how we can work with dictionaries. And then we've got the final data structure, which is a set. So a set is an unordered and unindexed collection of elements enclosed within curly braces. So what do I mean by unindexed? So when I say unindexed, this basically means that sets don't have any index to it. So we can't really access the elements with respect to their indexing. And also another thing to be noted is sets do not allow duplicate values. So let's say if you add a value 10, then you cannot add the same value again. So it will take the value only once. And this is how you can create a set. So you'll have curly braces over here and then you'll give in all of the elements inside it. So let me create my final data structure over here. So I'll type in 1, A, and then I'll give in a floating point value, let's say 3.78. Let me print out the set. So this is our set over here. Now what I'll do is I'll copy this and let me try to add some duplicate values. So I'll add 1 all of these times and then I'll also add A. Now let me print out S1 and then see what value do I get. So we see that duplicates are not allowed. 1, even though I have given around 5 or 6 times, it has been taken only once. And A I've given 2 times, but then again, it comes only once. So obviously set does not allow any duplicates inside it. Now let me go ahead and add some new values inside the set. So I'll type in s1.add hello world. Right, so I've added this new element. And if I want to add more than one element at a single time, then we've got this update method. So I'll type in s1.update and I'll give in a list of values. So I'll type in, let's say, Sparta, and then I'll type in 123. Then I'll give in, let's say, 3 plus 9j. Then let me print out s1. All right, so all of these elements have been added. Again, you see that the order of these elements is not preserved. It is random, right? So 3 plus 9j comes over here and then we've got 1, 123, right? So the random is not at all preserved. All right, so we are done with the basic data structures in Python, which were basically tuple, list, dictionary, and set. So now we'll head on to the flow control statements. And in flow control statements, we'll start with the if statement. So in real world, you will come across a lot of situations where you'd have to make a decision on the basis of a condition. So let's say if this happens, then you'd have to perform a set of actions. Else, you'd have to perform a different set of actions. So let's take this example to understand this better. So let's say it's raining and you'd want to play football. So if it's raining, then you can't do anything and you just have to sit inside. Else, so if it is actually not raining, then you can go out and play football. So these are some of the real world situations which can actually be represented in programming with the help of if-else statement. So let's go to Jupyter Notebook and work with if-else. So here I'll create 2 variables. So I'll give in the value of 10 to A and I'll give in the value of 20 to B. And then let me check if the value of B is actually greater than the value of A. So if B is greater than A, then I want to print out B is greater than A. So since this condition has been evaluated to true, that is 20 is greater than 10, and since this is true, this statement has been executed. So we get B is greater than A. Now let me actually flip it. So I want to check if A is greater than B, and if this evaluates to true, I want to print out A is greater than B. So we don't get any result, and that is because this condition has been evaluated to false. And since this condition has been evaluated to false, this statement has been skipped. So this is where else clause comes in. So let me use else over here. Now I'll type in if A is greater than B, then I'd want to print out A is greater than B. Else I'd want to print out B is greater than A. Right? So here the first condition evaluates to false, and that is why it is kept. And then we're given the else clause, and this condition is printed, B is greater than A. Now let's say if we have multiple conditions. So if we have three numbers and we want to check which is the greatest out of those three numbers. So this is where we would need if, else. So let me actually assign the values again. So I'll assign 10 to A, 20 to B, and I'll also assign 30 to C. So now I'd want to check if A is greater than B and A is greater than C. So I'll type in if A is greater than B and A is greater than C. And if this evaluates to true, I want to print out A is the greatest, and this evaluates to false. Then I'll type in elif, which stands for else if. So I'll give in the next set of conditions over here. So I'll type in B is greater than A and B is greater than C. And here I want to print out B is the greatest. So B is the greatest. And again, if this evaluates to false, I'll finally put in else, and I want to print out C is the greatest. So here the final result is C is the greatest. Now let's understand this whole thing properly. So first we come to the if statement, and then we check if A is greater than B and A is greater than C. That is 10 greater than 20 and 10 greater than 30. So both of these are false, and false would evaluate to false, and that is why we'll skip this statement over here. Then we'll come to else if, and we are checking if B is greater than A. So 20 is greater than 10, which is true. Then we'll check is 20 greater than 30, which is actually false. So true and false will evaluate to false, and again this is skipped. And finally we'll come to else, and we'll print out C is the greatest. So this is how we can work with if else. Now let's use the if statement with a tuple. So let me create a tuple over here. So tup1, and let me give some values. A, B, and C. So I have created this tuple. Now after this, I want to check if the element A is present in this tuple. So if A and tup1, then I'd want to print out A is present. Alright, so since this condition is evaluated to true, that is, the element A is actually present in this tuple, and that is why we print this out. Now let me just check if the character S is present in this, and if it is present, I want to print out S is present. So this condition evaluates to false, and nothing is printed out. Now similarly, let me go ahead and work with if and list. So if with list, and then I'll go ahead and create a list. So L1, and then I'll give in a bunch of values inside this. So 10, 20, 30, 40, and 50. Now I want to check if the first element in this list is actually 10. And if the value is equal to 10, then I want to change it to 100. So if L1 of index 0 is actually equal to 10, then I'd want to change this to 100, and then I'll finally print out this list. Right, so initially the first element in this list was 10. With the help of the if statement, I've changed it to 100. Now similarly, let me go ahead and work with if and dictionary. Dictionary with if. I'll create a dictionary, D1, and then I'll give in a bunch of key value pairs over here. So I'll type in the name of the fruit, which is mango, and then I'll assign the value, which is 10. And then the next fruit would be apple. And then the cost would be 20. And then the final fruit would be banana. and then the cost would be 30. Alright, so now I want to check if the value of mango is 10, and if it is equal to 10, then I'd want to add 100 more to this value. So if D1 of mango is actually equal to 10, then I'd want to add 10 more to this. So D1 of mango would be equal to D1 of mango plus 100, and then I'll print out D1 over here. Right, so initially the cost of mango was 10, then using the if statement I have incremented the value to 110. Right guys, so this is how we can work with the if statement. Now let's head on to looping statements. So looping statements are basically used to repeat a task multiple times. So let's understand looping statements with this example. So you have a bucket and you'd want to completely fill it up with a mug of water. So the condition is, while the bucket is not full, you will keep on adding a mug of water to it until it is full. So here the repetition task is you will have a mug of water and you will keep on pouring that into the bucket until it is full. So you're repeating a task until the final condition is met. And this is how the while loop works. So, and in looping statements, you basically have while and for. So we'll start with the while loop. So let's go to Jupyter Notebook again. So let me initialize a variable first. So I'll type in I equals 1 and then I'll use the while loop. So the condition would be while I is less than or equal to 10, I'd have to print out I. Now after this is done, I have to increment the value of I with 1. So let me print this out. So this is the result. Now let's understand this better. So initially I have a variable I and I have initialized it with the value 1. Then I'll start this while loop. So over here, I'll check if I is less than or equal to 10 and initially I's value is equal to 1. So is 1 less than or equal to 10? So it is true. And since this is evaluated to true, I'll come inside the while loop and I'll print out the value of I, which is 1. Then I'll increment the value of I. So 1 plus 1 would become 2. Again, I'll check if 2 is less than or equal to 10. And since 2 is less than or equal to 10, I'll again come inside the while loop and then I'll print out 2. Then again, I is incremented, I's value would become 3. So I'll check if 3 is less than or equal to 10. Again, it evaluates to true. I'll print out 3. And then this loop repeats itself until I's value becomes equal to 10. Right, so the final value would become equal to 10 and then I's value would become 11. So here I'll check if 11 is less than or equal to 10 and that condition would fail. And when the condition finally fails, we will come out of the loop. So this is how the while loop works. So now using the while loop, I want to print the 2 table. That is 2 cross 1 equals 2, 2 cross 2 equals 4 and 2 cross 3 equals 6 and so on. So I'll have the first variable initialized, which is I equals 1 and then I'll type in n equals 2. So I have my variables initialized over here. Now I'll start the while loop and this loop will go on till I's value is less than or equal to 10. Now inside this, I want to print out, so n and then cross I is equal to, I'll just put in n cross I. So let me print this out. So after this, I have to actually give in one more condition, which is I equals I plus 1. So if I don't increment the value of I, then it will go into an infinite loop. So I'll hit run. So we have this 2 table over here. So let me explain this properly. So initially I's value is 1. So I'll check if 1 is less than or equal to 10, which is true. So I'll come inside this and I'll print out 2 cross 1 is equal to 2. And then I'll increment the value of I, which is 2. Then I'll check if 2 is less than or equal to 10, which is again true. Then I'll come inside and then I'll print out 2 cross 2 is equal to 4. Then again, I's value is incremented. It becomes 3. Then I'll check if 3 is less than or equal to 10. And since this is true, I'll again come inside and then I'll print out 3 cross 2 is equal to 6. And this goes on until the I's value is equal to 10. And then I'll print out 2 cross 10 is equal to 20. And when we increment I's value again, it becomes 11. So is 11 less than or equal to 10? Well, it evaluates to false because 11 is greater than 10. right? So this is where the loop ends, and we have the final value, which is 2 cross 10 equals 20. Now let's use while loop with a list. So I'll basically create a list with a bunch of elements inside it, and with the help of while loop, I want to add 100 more to each of the value inside the list. So let me create the list over here, L1, and I'll add in a bunch of values over here. So 1, 2, 3, 4, and 5. So the list has been created now. Now I'll go ahead and initialize the variable I to be equal to 0. So this is also done, and then I'll start the while loop. So inside the while loop, I will basically check till I is less than. So let me remove these brackets over here. So while I is less than length of L1. So length of L1 would be 1, 2, 3, 4, and 5. So I would go from 0 to 4. And then I basically want to increment each element inside this list. So L1 of I would be equal to L1 of I plus 100. And then I also have to increment the value of I. So I would become I plus 1. And then finally, I'll print out the value of L1. Right, so initially the values in the list were 1, 2, 3, 4, and 5. And after running the loop, the values became 101, 102, 103, 104, and 105. So let's understand this loop. So initially, value of I was 0, and I'm checking if 0 is less than 5, which is true. So I'll come inside and I'll assign L1 of 0 to be equal to L1 of 0 plus 100. So it'll be 100 plus 1, which is equal to 101, right? So 1 would become 101, and then I's value is incremented by 1. So I's value is 1 now, and then again I'll check if I is less than 5, which is true. So I'll come inside and then I'll assign L1 of 1 is equal to L1 of 1 plus 100. So I'm adding 100 to this element 2. So it becomes 102. And similarly, this will go on till index number 4. And when it becomes 5, so 5 is not less than 5, and that is when we'll come out of this loop. So this is how we can work with the while loop. Now we'll head on to the for loop. So for loop is used to iterate over a sequence. So that sequence could be either tuple, list, dictionary, set, or even a string. And this is the syntax of for loop. So for value in the sequence, and then we'll give out the body. Now this might seem a bit vague or difficult to understand. So let's directly head to Jupyter Notebook and go ahead with the code. So let me start off by creating a list. So I'll type in L1 equals, and then I'll give in a bunch of colors inside this, which would be equal to blue, green, and then I'll just assign red to it. Now, once this is done, let me use the for loop and iterate over this list. So for I in L1, I'll just print out I. Right, so I have printed out each individual element of this list. So for I in L1, right? So when I say I, this value of I initially would be blue. So for I in L1, so L1 has these three elements, blue, green, and red. And initially I's value would be blue. So I'll come inside this list and I'll print out blue. And now it's incremented and I'll go to the next element in the sequence, which is green. So I will have green inside it. I'll come in and I'll print out green. And then I'll go ahead to the final element inside the list, which is red. So again, I'll come inside and I'll print out red. So this is how the for loop works. Now we can actually create nested for loop. So that would mean a for loop inside a for loop. So for this, let me create two lists and two separate for loops. So I'll create, let's say, color, and I'll assign some values. So the values are green, yellow, and pink. And then I'll also add another list, and then I'll name the list to be equal to item. And I'll add a bunch of items to it. So let's say the first item is chair, the second item is book, and the third item is phone. Now I'll start a for loop. So for I in color, I'll add another for loop over here. So for J in item, I will print out I, J. And this is what we have. So let's understand this. So we'll start with the outer for loop, which goes through this list over here, which is color. So for I in color, so initially I's value would be green. Now when the I's value is green, we'll come inside the for loop and we'll start the inner loop for J in item. So initially J's value is chair. So I'll print out green chair. Now again, I'll go back and increment the value of J. So then we have book inside J. So I'll print out green book. Then again, J's value is incremented. It becomes phone. I'll print out green phone, right? So now the inner loop is also done. I'll go back to the outer loop and then I'll increment green to yellow. So now I's value is yellow. So again, I'll come inside the loop and then I'll print out yellow chair, yellow book and yellow phone. Again, I'll go back to the outer loop and then the value of I is pink. Then I'll come inside and then I'll print pink chair, pink book and pink phone. So this is how you can work with nested loops. So now that we're done with the flow control statements, we'll head on to functions. So what exactly is a function? To simplify this, what we are basically doing is we are taking in a bunch of code, putting it in a simple module, and we can invoke it whenever we want to perform a specific task. So let's take this example of an ATM. So over here, depositing money inside the ATM would be one function, withdrawing money would be another function, and checking balance would be another function. Now, let's say if you want to deposit money and you would have to write around 100 lines of code to deposit money. And let's say if you want to deposit money around 100 times, then you'd have to write this 100 lines of code 100 times. Now, instead of this, it would be wonderful if we just had one deposit function and all we did was invoke this deposit function and we could deposit our money happily, right? So this is where functions come in. Similarly, when it comes to the withdraw function, we'll just have to add one function where we'll write in all of the bunch of code only once. And whenever we want to withdraw money, we'll just invoke this function. Similarly, whenever we want to check the balance, I'll just invoke the balance function and I can happily check the balance. So let's go to Jupyter Notebook and work with functions. So to create a function in Python, we'll be using the def method, and then after the ef, we'll give the name of the function. So I'll just create a very simple function and I'll name that function to be hello. And this needs to be followed with a parenthesis. So after this, I'll give in a colon and then I'll give in the body of this function. So this function just prints out hello world. So hello world, right? Now, if I have to invoke this function, I just have to type in hello with these parentheses. Alright, so if I want to print out hello world, all I have to do is copy this, paste it over here. So all I have to do is invoke this function and then I can happily print hello world how many times I want. Now after this, what I'll do is I will create a function where I'm taking an input value and adding 10 more to it. So I'll type def and I'll name the function as add 10, and this basically takes in a parameter value. So if you see this previous example, you see that I did not pass anything inside this parenthesis, but we can actually pass in a value inside the parenthesis, and I'm passing in x, which basically could be any arbitrary value. And I'll put in a colon over here. Now what this does is this returns 10 plus x. So it takes in x, adds in 10 to it, and then returns the final value. This is the function. So let me invoke this. Let me pass in 5 inside this function. So when I pass in 5, it will add 10 to it and it will return the final value, which is 15. Similarly, let's say I'll add an 100 inside this. So it will return a value of 110. So this was another example. Now going ahead, we'll check if a value is even or odd using a function. So I'll type def and then I'll just name this function as odd even. And again, this takes in a value. So I'll use the if condition and I'll check if x, and I'll check if x %2 is double equal to 0. So whatever input value is given, I will divide it with 2. And if the input is equal to 0, then I will just print out x is even, else I will print out X is odd. So I have created this function. Now let me invoke it and pass in a value. So I'll pass in 9 and let's see what is the result, right? So this function tells us that 9 is an odd number. Let me again pass in a number inside this. So I'll pass in 4. So this time this function tells us that 4 is even, right? So this is how we can create functions with Python. Now we'll head on to a major part in Python, which is object-oriented programming. Now, when you actually look around you, what do you see? You are surrounded with objects, aren't you, right? So you might have a laptop in front of you, you have a phone in front of you, you have a bike, you have a dog. So all of these are real world objects. And if you want to represent these real world objects in programming paradigm, then you would need something known as object-oriented programming, right? So simply put, you have all of these real world objects around you. And if you want to represent all of these real world objects in programming paradigm, that is where you'll go ahead and use object-oriented programming. So now when it comes to object-oriented programming, you basically need to understand two particular concepts, which are basically classes and objects. So as it is stated over here, a class is basically a template or a blueprint for real world entities. Now, what do I mean by it? So when I say template, a template would comprise of two things. One is properties of the object and the next is behavior of the object. So let's take a phone. Now a phone would have certain properties associated with it and it will also have certain behavior associated with it. Now the properties of a phone could be its color, its cost and its battery life. So what is the color of the phone? How much does it cost? And how long does the battery last? So these are some properties which are associated with every single phone that everyone has. And then all of the phones have certain behavior common to all of them. So you can make calls with a phone, you can watch videos in a phone, and you can also play games in a phone, right? So these are the properties and behavior associated with a phone. Now a class basically combines these properties and behavior in one single template. So that is a class. Now let's understand what exactly is a object. So objects are basically specific instances of a class. So as I've told you, a class is a general template. And when you want a specific instance of that general template, that is when you have an object. So when I say phone, that phone would be your class. And the objects of that phone would be Apple, Motorola, and Samsung, right? So Apple, Motorola, and Samsung would have the general template of a phone. So they will have the general properties and they will also have the general behavior. So if these objects are of the same phone class, then you will get those same properties, which is basically all of these phones would have color associated with them, cost associated with them, and then you will also have battery life associated with them. And when it comes to behavior, these three phones would have those functionalities common. Right? So in all of these three phones, you can make phone calls, you can play games, and you can also watch videos. So this is what I mean when I say objects are specific instances of a class. All right. So now that we know what exactly is OOPS and what exactly are classes and objects, let's go ahead and perform some object-oriented programming. So let's go ahead and create our first class. And to create a class, we will have to use the class keyword and then we'll give in the name of the class. And by convention, the first letter of the name of the class needs to be capital. So I'll type in capital P and then I'll follow it up with HONE. So it is phone. And then inside this, I will give in the properties and the behavior of the class. So a phone, basically with the help of a phone, you can make phone calls and you can play games. So I'll start off by creating methods. So the first method is to make a phone call. So I will name this method as make call. And then this will have something known as self. So this self basically means that this method belongs to the instance which invokes it. So this might be a bit confusing, but once we actually create an instance of this class, it'll become very clear to you. So we have created this method, and when someone invokes this method, I'll just type in making a phone call. And then I'll give in the second method, which is play game. Again, this will have this self attribute. So again, the self attribute basically stands for whichever instance invokes this method, it belongs to that. All right. So I will print out playing game. All right. So I have created this class, which is basically the general template of a phone. Now I will go ahead and create the object. So to create an object, I will type in P1, which is basically the instance or the object of this class. And I will have to type in the name of the class followed by the parenthesis. And I have successfully created the instance of this phone class. Now, if I have to invoke these methods from this object, so I will type in the name of the instance. I'll use the dot operator, and then I can directly give the name of the method in this class. So if I want to make a phone call, I just have to type in p1.makeCall. So p1 is the name of the instance. After that, I'll give in the dot operator, and then I'll give in the name of the method inside this class, which is makeCall. Right? So now I have successfully invoked this method of this class. So P1 is an instance of this class, and I'm able to access this method with the help of this instance. Similarly, I'll type in P1.playGame. Right. So now I have started playing game. Right. So this is how we can create instances. Now let me actually go ahead and add some parameters to the methods inside this. So again, I'll create a new class. Or basically I'm modifying this class, I'm not creating a new class. So I'll type in class, so this will be phone, and then I'll create a new method, and this will be basically to add the color of the phone. So I'll type in add color. So now every method inside the class needs to have this self attribute, and then after that I'll give in another parameter, which is basically color, and inside this I will set self.color equals color. Now you have to understand that this self.color and this color are actually different. So this color is the value when someone gives while invoking this method, while this self.color is the inbuilt attribute inside this class of that particular instance. So if this seems confusing, let me repeat it again. So this color which you see, it is basically the parameter or the value when someone gives in while invoking this method. And the self.color is the value which is being assigned to the color attribute of the instance which is being invoked. So let me actually go through, and this will become very clear to you, right? So I have created this method, and then similarly, I'll add another method called as add cost. So again, this will have two parameters. First is self, and then next would be cost. And then I'll type in self.cost equals cost. So this is also done. So going ahead, I will create one more method where I'd have to show the color and show the cost. Right. So till now I have only taken the color from the user and taken the cost from the user. Now I also have to print it out. So I'll create a new method called as show color. This would have self, and this would basically return the color. So self dot color, and after this I would have show cost. Again, the parameter would be self, and this would be returning the cost. So that would be self dot cost. All right. And then I'll again create those two basic functions, which are basically making a phone call and playing a game. So definition of make call, this would be self. I am just printing out making a phone call. After this, I'd have to create the final method, which is play game. Again, this will have the self attribute, and then I'll print out playing game. Right, so I have successfully created this class. Now I'll go ahead and create an instance of this class. So I'll type in p2 equals phone. Now let me go ahead and add the color and cost of this phone. So I'll type in p2 dot color. Now let me go ahead and add the color and cost of this phone. So I'll type in p2 dot color and the now let me go ahead and add the color and cost to this phone. So I'll type in p2 dot add color and the color of this phone is, let's say, blue. Now similarly, I also want to add the cost of this phone. So p2 dot add cost and the cost of this phone is, let's say, $200. Right. Now I have assigned the color and the cost. Now let me show the color and the cost. So I'll type in p2 dot show color. So we see that the color of the phone is blue. Now let me also print out the cost. So p2 dot show cost. So we see that the cost of the phone is 200. All right. So now what you see is this self dot cost equals cost or self dot color equals color. So this color is basically this value which we are passing in when we are invoking the function, right? So this blue is going over here and this is being assigned to the attribute color of this class phone. So to make it more clear, let me actually create one more instance of this class and let me add the color to that. So p3 equals phone. So I have created this and then I'll type in p3 dot add color and the color of this phone would be red. Now let me show this out, p3 dot show color. So the color of this instance of the phone p3 is red. Now let me type out p2 dot show color, which is blue. All right. So this self, what you see, this basically denotes the instance which is invoking the method, right? So over here, when we invoke the add color with the p2 instance, this self attribute was with respect to the p2 instance. And similarly over here, when we were invoking the add color with respect to the p3 instance, the self attribute was of the p3 instance. This is how we can add parameters to our methods and invoke them through our objects. Now let's head on to an important concept in object-oriented programming, which is inheritance. So what comes to your mind when you hear the word inheritance? So simply put, inheritance basically means that when something acquires the properties of someone else's or something else's, right? So let's say you are inheriting your features from your father, or you are inheriting the land or the property from your ancestors, right? So either it could be materialistic inheritance or it could be the features or the looks from your parents, right? So inheritance is basically acquiring properties from another person or another thing. And when it comes to object-oriented programming, it pretty much means the same thing. So over here, you will have two classes or more than two classes. One class inherits the features or the properties of another class. And that is pretty much the concept of inheritance in object-oriented programming. So let's again head back to Jupyter Notebook and start with inheritance. So to show inheritance over here, I'll just create an extension of the original class. So what I'll do is I will create a new class and I'll name this class as iPhone, and this iPhone will be inheriting from the base class phone which we had created earlier, right? So this is the base class and this new class iPhone would be inheriting from this base class. Now this would have one extra method which is cure cancer. Now, as you know, iPhone is very famous and it's famous because it can actually cure cancer. So that is why it costs so much. So that is amazing, isn't it? So cure cancer, I'll give in the self attribute and then I'll just print out I can cure cancer. So I have created this new class. Now let me create an instance of this. So IP1 equals iPhone. So I have created the instance. Now let me go ahead and invoke the methods. Now as you can see, this class or this instance of the class has the methods add color and add cost. Now even though I have not explicitly stated these methods inside this class, they are still a part of this class because it is inheriting from the base class, which is Python. And since these two methods are part of the base class, I can automatically invoke these two classes. So let me assign a color to this phone. So the color of iPhone is gray. Now I'll go ahead and also set in cost. So IP1 dot add cost, and the cost of iPhone would be, let's say, $899. And then let me invoke the method which is only there in the iPhone class. So ip1.cureCancer. All right, so I can cure cancer, right? So this is how inheritance works in Python. Right, so we're done with object-oriented programming as well. Now we'll go ahead and work with some packages in Python. So we'll start off with the NumPy package. So NumPy basically stands for numerical Python and is the core library for numeric and scientific computing. So that's too much of information. So simply put, NumPy basically has a multi-dimensional array. Now to process those multi-dimensional arrays, you have certain functions and you have certain operations pre-built in the NumPy package. And that is how you can work with these NumPy multi-dimensional arrays. So you can perform all sorts of numerical and scientific operations on this NumPy array. So let's go to Jupyter Notebook and work with this very famous package called as NumPy. So to start working with the NumPy library, you'd have to first import it. So you'll type in import NumPy as np. Now this is just an alias so that I can keep invoking this package whenever I need, right? So np is the alias. Now before you can actually go ahead and work with this library, you'd have to install it. So to install it, since we are working with Anaconda, let me open this up, right? So to install this, you'd have to type in pip install NumPy. Right? But then again, if you're working with Anaconda, NumPy, Pandas, and Matplotlib, all of these come pre-installed in Anaconda. But then again, if you're working with Pycharm or if you're working with any other Python IDE, then you'd have to manually install NumPy. All right. So NumPy is already installed and I have successfully imported NumPy into my system. Now it's time to go ahead and create my first multi-dimensional array. So once you install NumPy and you invoke the library, you have to create a NumPy array. And you can create both a single dimensional array as well as a multi-dimensional array in NumPy. So to create a NumPy array, you just have to type in np.array. So as I've already told you, np is basically the alias for NumPy. So you'll type in np.array and this basically takes in a list of values or a list of lists. So to create a single dimensional array, what you'll do is you will pass in a list inside this np.array and this will give you a NumPy array. Similarly, to create a multi-dimensional array, you will pass in a list of lists, right? So this is one list and inside this you've given two lists, right? So the first list comprises of the elements 10, 20, 30 and 40 and the second list comprises of the elements 40, 30, 20 and 10. So let's go ahead and create our first NumPy arrays. So I'll create a single dimensional NumPy array first. So let me just add in this comment, single dimensional NumPy array. So as I've already told you, to create a NumPy array, we'd have to type in np.array and inside this I'll give in a list of values. So let's say the list of values are 10, 20, 30, 40 and 50. So I'll type in 40 over here and 50 over here and I'll store this in a new variable and name that variable as n1. Now let me print out n1 over here. So this is our NumPy array. Now let me also check the type to be sure. So type of n1 and this shows us that this is a NumPy nd array or n dimensional array. Now let's go ahead and create a multi-dimensional array. So I'll type in multi-dimensional. So over here, I'll be storing this value in n2. So np.array. Now you have to keep in mind that you pass in a list of lists over here. So I'll create one list and inside this, I'll create the first sub list and the values would be 10, 20, 30. And then I'll create another sublist. The values I'm giving are 30, 20 and 10. Now let me print out n2. So this is my multi-dimensional array which comprises of 2 rows and 3 columns. So the first row comprises of 10, 20 and 30 and the second row comprises of 30, 20 and 10. Now again, let me check the type of this. So type of n2. So type of n2 is again NumPy n dimensional array. And this is how we can create NumPy arrays in Python. So guys, this is just the starting and you can do a lot of stuff with these NumPy arrays. Right. Now we'll go ahead and see how can we initialize a NumPy array with all zeros. So let's say if we want to create a simple row array which comprises of 2 zeros, then we have this zeros method. So np.zeros, you are invoking this zeros method from the NumPy package. So when you type in np.zeros, and then you have to give in the dimensions of it. So the dimensions of the NumPy array are 1 cross 2, and then you'll get this. Similarly, if you want to create a 5 cross 5 NumPy array which comprises of only zeros, then you just type in np.zeros, and inside that you will give in the values. So let's initialize our NumPy array with zeros over here. I'll type in n1 and then np.zeros. So I want the size of the NumPy array to be 1 cross 2, and then I'll print this out. Right, so I have successfully created my NumPy array of dimensions 1 cross 2, which means 1 row, 2 columns, and the values are just zeros. Now similarly, I'll create another NumPy array. So n1 equals np.zeros, and I want this to be a, let's say, 6 cross 6 NumPy array which comprises of only zeros. Again, let me print in the value of n1. Right, so I have created this NumPy array which is of dimension 6 cross 6, and it comprises of only zeros. Now similarly, let's say if you want to initialize a NumPy array with the same number. So this is where we have the full method from NumPy. So we have to type in np.full, and this takes in 2 parameters. So the first parameter is the dimension of the NumPy array, and the second parameter is the value with which you'd want to fill up your NumPy array. So over here, I am creating a NumPy array of dimension 2 cross 2, and the value which I'm filling it up with is number 10. So let's create this. So I'll name this as n1 again, and I'll type in np.full. I'll give in the dimension. I want to create a 3 cross 3 NumPy array, and I want to fill it up with the number 7. And then let me print out n1 over here. So we have created this 3 cross 3 NumPy array where all of the elements are just 7. Again, we can initialize our NumPy array in a different way. So if you want to initialize our NumPy array with a particular range in mind. So let's say I want my NumPy array to be filled with all of the values from 10 to 20. So basically the interval is 1, or the skip value is 1. So I'll have 10, 11, 12, 13, 14, 15 going on till 19, right? So I want to fill up my NumPy array with a particular range. So this is how I can do it. Now, another form is I basically give a skip value. So when we don't give the third parameter, a range automatically takes the skip parameter as 1. So when we look at the second example over here, the range is basically from 10 to 50, but the skip value is 5. So your first number would become 10, second number is 15, 20, and then this goes on till 45. So you have to keep in mind that this last number which you see, this is exclusive. It is not inclusive. So when you add 5 more to 45, if it is less than 50, only then you'll get the last value. If it is equal to or greater than 50, then you will not get that value. All right, so let's go ahead and initialize our NumPy array with a particular range. So again, I'll type in n1. So this would be np.arange, and inside this, I will basically give in the range with which I want this NumPy array to be filled with. So I want this to be filled starting from 1 going on till 11. And then let me print this out. Right, so this NumPy array, the values start at 1 and go on till 10. Now similarly, let me create another NumPy array with a specific skip value. So n1 equals np.arange, and let's say I want the range to be from 100 and going on till 300, and I want the skip value to be equal to 50. So let me just print out n1 now. Right, so this is my NumPy array. So 100 is the starting value, 250 is the last value, skip value is 50. So that is why I get 100, 150, 200 and 250. And when you add 50 more to 250, it becomes 300. And since 300 is not inclusive, that is why you will not have that number over there. Now let's see how can we initialize our NumPy array with random numbers. So if you want to initialize our NumPy array with random integers, then we've got this rand_int sub method from the random method. So again, you will set the range of the numbers from which you want the random numbers over here, right? So the range of the numbers is 1 and 100. So starting from 1, going on till 100, you will choose 5 random numbers. So let's go to Jupyter Notebook and work with this. So n1 equals np.random.randint, and then inside this, let's say I want 10 random values, and the values would be coming in the range between 100 and 200. So I want 10 random values. Let me print out n1. Right, so these are the 10 random values between 100 and 200. So that was how we could initialize our NumPy array in a lot of different ways. Now let's see how can we check the shape of our NumPy array. So checking the shape of our NumPy array would basically give the number of rows and number of columns present in the NumPy array. So all you have to do is create a NumPy array first and then use this shape method. So when you use the shape method, this will tell you the number of rows and number of columns present in this NumPy array. Now, with the help of this shape method, you can actually change the shape of your NumPy array. So initially, when you are initializing it, this NumPy array had 2 rows and 3 columns. But with the help of this shape method, you can change it to 3 rows and 2 columns. So let's go to Jupyter Notebook and let's see this visually. So again, n1, and let me create a NumPy array over here. np.array. Let me give in some values. So let's see 1, 2, 3, and 4. And I actually have to give in a list of lists. So let me cut this and paste inside this. And then my second sub list would be 5, 6, 7, and 8. So I have created n1 over here. Let me check the shape. n1.shape. So the shape of this NumPy array is 2 cross 4. This would mean we have 2 rows and 4 columns in this NumPy array. So that would basically amount to 8. Now, instead of 2 cross 4, I want this NumPy array to be of the shape 4 cross 2. Or in other words, I'd want to have 4 rows and 2 columns. So all I have to do is type in np.shape equals 4 cross 2. So this is done. Now let me print out n1. Right, so initially this was our n1 array, which was of the shape 2 cross 4, and then we reshaped it. Now this is how it looks like. Now once we know how to initialize our NumPy arrays and how to check the shape of our NumPy arrays, let's go ahead and perform some simple mathematics on top of these NumPy arrays. So we'll look at some basic addition operations. So to add two NumPy arrays, we will just use the sum function from the NumPy package. So over here, I am creating two NumPy arrays, n1 and n2. And when I use the sum method over here, I'll pass in n1 and n2 as a list, right? So this will add all of these individual elements from both of these NumPy arrays. So when you add 40, 30, 20, and 10, it will give you a complete value of 100. Now, you can also set the axis. So if you don't set the axis, then it will add all of the individual elements which are present. So when you set axis to be equal to 0, then it actually does vertical addition, right? So what I mean by vertical addition is it would add the individual elements of each index of this array. So index is 0 over here for n1 and n2. When you add 10 plus 30, it would become 40, and that is what you have. Similarly, when you come to index number 1 and you add 40 plus 20, you get 60, and that is what you have. Now, instead of axis to be equal to 0, when you set the axis to be equal to 1, you basically are doing horizontal addition. That is, you are summing up the values which are present in one individual NumPy array. So here, 10 plus 20 becomes 30, and that is what you have. And over here, when you add 30 plus 40, it becomes 70, and that is what we have over here. All right. So let's go to Jupyter Notebook and perform these methods. So again, let me create a new NumPy array. I'll call it A over here. So it will be np.array, and I'll pass in a list of values over here. That would be 10 and 20. And then I'll create another NumPy array. So I'll type in np.array again, and the values inside this would be 30 and 40. So I have successfully created my two NumPy arrays. Now going ahead, let me use the sum method. So it would be np.sum, and inside this I'll just pass in a comma b, which are basically the NumPy arrays which I've created, and I get a complete value of 100. Now let me go ahead and set the access. So np.sum, I'll type in a comma b, and then let me set the access. So I am setting the access to be equal to 0. And when I set the access to be equal to 0, as we have already seen, we have vertical addition over here. So 30 plus 10 gives you 40, and 40 plus 20 gives you 60. All right. Now let me go ahead and set the access to be equal to 1. So I'll pass in a comma b, and I'll set the access to be equal to 1. Right, so 10 plus 20 becomes 30, and 30 plus 40 becomes 70. So those were some basic addition operations on top of the NumPy arrays. Now let's see how can we join different NumPy arrays. So we've basically got these different methods. We've got vstack, which stands for vertical stack. Then we've got headstack, which stands for horizontal stack. And then we've got column stack. So when it comes to vstack, what we do is we join these NumPy arrays row-wise. So over here we have two NumPy arrays, n1 and n2. And when we use vstack method upon these two NumPy arrays, we are basically joining these two NumPy arrays row-wise. Then we have the headstack function. So when it comes to headstack function, we are combining these two NumPy arrays column-wise. So when I say column-wise, we will take in this first NumPy array, and then we'll attach the second NumPy array to the back end of this. Then we have column stack, where we basically take in two single dimensional NumPy arrays, and then we stack them column wise to create a two-dimensional array. So as we see over here, we've got two one-dimensional arrays, right? So n1 and n2, and when I use column stack on top of this, I get a two-dimensional array. So over here, these two are stacked column wise. All right. So let me go ahead and use these three functions. So let me create n1 over here. So n1 is equal to np.array, and let me give in the values 10, 20 and 30. Then n2 would be equal to np.array, and the values inside this would be, let's say, 30, 40 and 50. So I have created n1 and n2. Now it's time to use vstack on top of them. So I'll type in np.vstack, and inside this I'll pass in n1 and n2. So let me get the result, right? So I have horizontally, so I have stacked these two columns row wise. Now similarly, instead of vstack, let me use horizontal stack. So I'll type in head stack over here, right? So when I use head stack, I get this. So I'm horizontally stacking these two NumPy arrays. And then finally, let me use np.column stack, and I'll pass in n1 and n2. And I have taken these two individual single dimensional arrays, so 10, 20, 30, 30, 40, 50, and I have stacked them column wise to create a two-dimensional NumPy array. Right, so this brings us to the end of this NumPy module. Now let's go ahead and work with another interesting package in Python, which is Pandas. So Pandas stands for panel data, and it is the core library for data manipulation and data analysis. So as NumPy provides us a multi-dimensional array, similarly, Pandas provides us a multi-dimensional data structure for performing various data manipulation operations. So it provides us both a single dimensional data structure and a multi-dimensional data structure. So as we see over here, the single dimensional data structure is called as the series object, and the multi-dimensional data structure is called as the data frame. And we'll mostly working with the data frames in Python. So data frames become extremely important when it comes to data science operations. So all of the machine learning algorithms which you apply, linear regression, logistic regression, decision tree, and so on. So all of these are applied on data frames. And this is because all of the data sets which you have, all of the CSV files which you have, text files which you have, they can be converted to a data frame in Python, and all of the manipulations can be done on this data frame. All right, so let's start off with the Pandas series object. So as you see over here, a series object is basically a one-dimensional labeled array. So the difference between this and a NumPy array is, when it came to the NumPy array, it was not labeled, but the series object is a one-dimensional labeled array. And this is how you can create a series object. So before we go ahead and create a series object, first we'd have to invoke the Pandas library. So we'll type in import pandas as PD. And PD again over here is just an alias for pandas. So after we invoke pandas, we'll type in pd.series. So over here, you'd have to keep in mind that S is capital. And inside this, we'll pass in a list 1, 2, 3, 4, and 5. And we have created this series object. So let me start off by importing pandas. So I'll type in import pandas as PD. So let me just wait till this package is loaded. So that is done. Now again, since I'm using Anaconda, pandas comes pre-installed in it. So if you have to manually install pandas, this is what you have to do. Open up Anaconda prompt, and then you'd have to type in pip install pandas. So once you do that, pandas will be installed. All right. So I have imported the pandas library. Now let me go ahead and create my first series object. So I'll name this object as S1 and I'll type in pd.series. And inside this, I'll basically pass in a list. So the list would comprise of the values 10, 20, 30, 40, and 50. So let me print in S1 over here. So this is my series object. So as you see over here, these are the values, and these values are of type integer 64. So integer 64-bit. And these are the labels associated with each of these values. So 0 is the label associated with 10, 1 is the label associated with 20, 2 is the label associated with 30. So you can either call these index values or the labels associated with these numbers. So now you must be thinking that, is there a way that we can actually change the index of a Pandas series? Well, you can. So all you have to do is include this index attribute and then give the labels which you want for these. So as you see over here, initially the labels were 0, 1, 2, 3, and 4. Now after that, you just use this index attribute and then change these values to A, B, C, D, and E. Right, so let's perform this. So let me go ahead and add the index to this. So as you see over here, initially the labels were 0, 1, 2, 3, and 4. Now let me go ahead and change the index. So this time I'll set the index to be A, B, C, D, and E. Now let me print out S1. So as you see over here, these were the initial index values and I have changed them to these over here. So we saw how to create a series object from a list. Now let's see how can we create a series object from a dictionary. So as you see over here, we'll just pass in this dictionary inside this series object. And one thing to note over here is, if you don't specifically set the index values, the key automatically becomes the index and the values would automatically become the actual values inside the series object. So I'll reiterate it. The keys would become the index values and the values would become the actual values of the series object. So let me create a dictionary over here. So D1, and I'll set the key to be equal to K1 and the value to be 10. Then I'll set the key to be K2 and the value is 20. Then the key is K3 and it is 30. I have created this dictionary. Now again, let me go ahead and create a series out of this. So pd.series, and I'll pass in the dictionary inside this and I'll store this in S1. So let me print out S1 again. Right, so this is my series object which has been created from this dictionary. So as we see over here, the keys have become the index values. So K1, K2, K3 are the index values and 10, 20, and 30 are the actual values of the series object. Right, so that was all about the single dimensional data structure series. Now we'll head on to the most important data structure in Python, which is a data frame. So as it is stated over here, a data frame is basically a two-dimensional labeled data structure, and it comprises of rows and columns. So this what you see, so you've got 3 rows over here and 2 columns over here. And normally when it comes to a data frame, all of the elements inside one column would have the same type. So as you see, this is the name, and the names are normally strings. So Bob is a string, Sam is a string, and Anne is a string, right? And then we've got marks. So marks is another individual column. And when you look at the values inside this marks column, you see that 76, 25, and 92, all of these are integer values, right? So this is how a data frame looks like. And to create a data frame, this is how you can do it. So all you have to do is use the pd.dataframe method, and then you can create it from a dictionary over here, right? So the key becomes the column name over here, and these values become the row values over here. So let me create a data frame. So I'll name this data frame as student, and the first column would actually be the name of the student. So I'll type in student name. So this is actually the key, and then I'll give in the list of values. So the list of values would be Bob, and then we've got Sam. After that, we've got Julia, and then we've got Charles. So these are the student names, and then let's go ahead and give in some marks to these students. So I will create the next key, which would be student marks. So I'll type in student marks over here, and then I'll give in a list of values. So let's say Bob has scored 87 and Sam has scored only 13 marks. Then we've got Julia, who has scored an impressive 99. And then we've got Charles, who has scored an average 67. So I have successfully created this dictionary. Now it's time to create a data frame out of this dictionary. So I'll type in pd.dataframe, and inside this, I just have to pass in this dictionary. I'll click on run, and I have successfully created this data frame where the key over here becomes the column name, and these list of values for a particular key become the row values for that column. So Bob, Sam, Julia, and Charles are the list of values or the row values for this key student name, which is the column name. Similarly, 87, 13, 99, and 67 are the row values for this key student marks. So now that we know how to create a data frame, let's go ahead and perform some inbuilt functions on top of this data frame. So we'll be working with this basic functions such as tail, head, shape, and describe. So to work with all of those inbuilt functions, we'll start by reading a CSV file as a data frame first. So again, let me perform the basic steps. So I'll type in import pandas as pd. Now to load a CSV file, I'd have to type in pd.read_csv, and inside this I'd have to give in the name of the file. So we'll be working with this iris.csv file, and I'll be storing this in a new object, and I'll call that object as iris. So now I want to have a glance at the first 5 records of this iris data frame. So to have a glance at the first 5 records, I'll just type in iris.head. Right, so I've got this first 5 records of the data frame. Now let's understand this data frame properly. So this has got 5 columns, which are basically sepal length, sepal width, petal width, and species. So these are basically the different features of the species of the iris flower. So you've got 3 different species: Setosa, versicolor, and virginica. And for all of these 3 different species, we've got the sepal length, sepal width, and petal width. So as we already saw over here, the head function helps us to have a glance at the first 5 records of this data frame. Now, if I want to have a glance at the first 10 records, then all I have to do is type in 10 inside this head function. Then we'll have a glance at the first 10 records of this data frame, right? And if I want to have a glance at, let's say, the first 100 records, then I'll just type in iris.head 100. Right, so these are the first 100 records where the index value starts at 0 and it goes on till 99. Now, analogous to the head function, we also have the tail function. So I'll type in iris.tail. Now this tail function would give me the last 5 records of this data frame. So this starts at index number 145 and goes on till index number 149. Similarly, if I want to have a glance at the last 10 records, then I'll just pass in 10 over here. Right, so these are the last 10 records of this iris data frame. Now, these are the head and tail functions. So there is also this describe function. So I'll just type in describe over here and let's just see what it does over here. So this would basically describe this entire data frame in terms of all of these different measures. So we've got count. So this count is basically the number of records present for each of these different columns. So there are 150 records for sepal length, similarly 150 for sepal width, petal length and petal width, right? So these are basically the different count values of all of these columns. And then we've got the mean value. So this is the mean value of sepal length, sepal width, petal length and petal width. And similarly, we've got the minimum value, standard value, 25 percentile, maximum value, and so on. So these are some basic functions which can be implemented on top of any data frame. So now going ahead, we'll see how to access individual rows and columns from our data frame. So to do that, we've got the iloc and the loc methods. So let's start with the iloc method. So first we'll give in the name of the data frame and then we'll just type in .iloc. So this .iloc basically stands for index location, and this is how we can extract some specific rows and columns from this entire data frame. So over here, what we are doing is we are extracting the first 3 records from this data frame and the first 2 columns, right? So the index values go from 0 to 3. So 0, 1, 2, and then the column values are 0 to 2, right? So 0 and 1, sepal length and sepal width. So this is how we can extract a subset of the data frame from this entire data frame. So now let me again print out the head of this. So iris.head. This is my data frame over here. Now let's say I want a subsection which comprises of the row numbers starting from, let's say, 99 and going on till 126. And I want only the petal length and the petal width column. So to do that, I'd have to type in iris and then I'll type in loc. I'll give in this square braces over here. I'll put in a comma. Now, whatever you given on the left side of the comma, that would denote all of the rows which you'd want to extract. And whatever you put in on the right side of the comma, that would denote all of the columns which you'd want to extract. So as I've said, the row numbers which I want to extract are from 99 to 126. So indexing will start from 99 and go till 127. And then the column values would be 0, 1, 2, and 3. So this will go from 2 to 4. So I'll just put in 2 to 4 over here and I'll store this in a new data frame and I'll name that to be iris1. So let me print out iris1 over here. Right, so this is our data frame iris1, which comprise of only the columns petal length and petal width, right? And the row numbers start from 99 and go until 126. Now, similarly, let's say if I want to extract all of the records starting from row number 10 and going on till row number 20, and I want only these 2 columns, the sepal length column and the species column. So let me show you guys how it's done. So this time I'll name the data frame as iris2 and I'll type in iris dot, I will type in iloc over here, and this would go from 10 to 21. And after this, I will just give in the column values. So again, I will take in a list over here, and inside this, I will give in the index of the first column, which is basically 0. And then I'll give in the index of the final column, which is 4 over here. I'll click on run and let me print out iris2 over here. Right, so this is my subsection of the entire data frame where I have row numbers starting from index number 10 going on till index number 20, and these are the 2 columns which I've extracted. So sepal length and species. So this is how I can work with the iloc method. Then analogous to the iloc method, we also have the loc method to extract individual rows and columns. So the only difference is, instead of giving the index values over here, we give in the labels of the columns over here, right? So over here, when it comes to rows, we'll similarly give in the index values of the rows. And over here, when it comes to columns, I will give in the names of the columns. So let's work with iloc. Now let me print out the head again, iris.head. Right, so this is my data frame over here, and this time I want all of the records starting from row number 33 and going on till, let's say, 44. And I'll store this in iris3, so this will be iris.loc, and inside this has to go from 33 to 44. And then the names of the columns which I want to extract would be sepal width and petal width. Now you have to keep in mind that you given the column names properly, right? So if you make a spelling mistake, then there would be an error over here. So I'll type in sepal width, and then I'll give in the name of the next column, which is basically petal width. Now let me print out the subsection. So I'll just print in iris3. Right, so these are all of the records starting from row number 33 going on till row number 44, and these are the two columns which I've extracted, sepal width and petal width. Right, so till now what we did is we extracted some individual rows and columns with the help of .loc and .iloc. But now we'll actually perform data manipulation operations where we'll be extracting records on the basis of a condition. So let's go ahead and do that. Now the condition which I want to specify is I want only those records from this data set where the sepal length is greater than 5. So let's see how can we do that. So first I'll give in the name of the data frame, which is iris, and I'll put in quotes over here, and then I'll give in the name of the column, which is basically sepal length. So I want to extract only those records where the sepal length is greater than 5. So I will basically give a condition that this sepal length has to be greater than 5. Now let me click on run and let's see what do we get. So we basically get a bunch of true and false values. Now what does this mean? So this means that wherever you have the true label, this condition has been satisfied, and wherever you have the false label, this condition has not been satisfied. So we have the true label for the 0th record over here, and that is because the sepal length is greater than 5. Similarly, we have a true value over here, and that is because the sepal length is greater than 5, right? So wherever you have the true value, that is where you have the sepal length to be greater than 5. Now we've done this. Let's go ahead to the next part where we actually have to extract those records. Now we just have a bunch of true and false values. So to extract the records, again, I'll type in iris, I will give in braces, I will cut this, and I will paste this inside this iris data frame. So what I'm doing is I will be extracting only those records where this condition evaluates to true. I'll click on run, right? And this is what we have. Now, if you look at the sepal length column, then you'll see that all of these values are greater than 5. So what we basically did is first we started off by giving the condition, and then we put in this condition again inside this iris data frame. So this gave us only those records where this condition was satisfied. Right, now let's go ahead and perform similar operations. So this time I want only those records where petal length is greater than 2 and the species is equal to Virginica. So let's check that out. So let me cut this first and given the condition. So the first condition would be iris, and then we want the petal length to be greater than 2. So I'll type in petal underscore length, and this has to be greater than 2. Now I will enclose this within round brackets. After that, I will give in the AND operator because I want both of these conditions to be satisfied. So I'll go ahead and give in the second condition. So the second condition is iris, and this time the name of the column is species. So this has to be equal to Virginica. So I'll just set Virginica over here. Right, so these are the two conditions. Now I will cut this out, and again I'll type in iris and paste it inside this. And I will store this in a new data frame and name that to be iris final. Now let me check the head of this. So iris final dot head. Right. So we see that we have extracted only those records where the petal length is greater than 2. Right. So here you see petal length is greater than 2 and the species is equal to Virginica. So we have given multiple conditions to extract these records. Now, similarly, we can give as many conditions as possible. You can give 2, 3, 4, or 5, as many conditions as you want. So let's complicate this a bit and we'll give in 3 conditions over here. So this time I want the sepal length to be greater than 6, sepal width to be greater than 3, and petal length to be also greater than 3. So let's give in all of those 3 conditions and let's see what do we get. So I will type in iris, and my first condition would be sepal length has to be greater than 6. I'll put in braces, and this is my first condition. After that, I'll give in the AND operator, and then given the second condition, I'll type in iris, and the sepal width has to be greater than 3. So I'll type in sepal width. This has to be greater than 3, and then I'll give in the final condition, which is basically the petal length has to be greater than 6. So iris, and then I'll give in petal length over here. This has to be greater than 6. Let me cut all of this. Let me paste it inside this. Alright, so I have given my 3 conditions over here. Let me cut this entire thing out. Let me type in iris over here and I'll paste it over here. Alright, I will store this in, let's say iris random. So this would become iris random dot head. Right, so we have these records where the sepal length is greater than 6. The sepal width is greater than 3, the petal length is greater than 3, and the petal length is greater than 6, right? Now let me actually remove this head and let's see how many actual records satisfy this. So see that there are only 3 records out of these 150 records where these 3 conditions are satisfied. That is, the sepal length is greater than 6, the petal width is greater than 3, and the petal length is greater than 6. Right, so these were some different data manipulation operations which we could perform on the iris dataset. So that was data manipulation. Now we'll head on to data visualization. And to perform data visualization, Python provides us a package called as Matplotlib. And with the help of Matplotlib, you can create beautiful graphs such as bar plots, scatter plots, histograms, and a lot more. So let's go to Jupyter Notebook and work with these graphs. So we'll start off by importing the pyplot submodule from the Matplotlib library. So I'll type in from Matplotlib import pyplot as plt. So I have imported this, and we also have to create some NumPy arrays. So for that purpose, I would also have to import NumPy. So I'll type in import NumPy as np. So we have imported the required modules. So now that we have the required packages, our first plot which we'll be making is a line plot. So to create this line plot, we would require x and y values. So let me start off by creating the x values. So x would be equal to np.aRange, and I want the value starting from 1 and going on till 10. Right, so let me just print this out first. So I've got my x values ready. Now let me also create my y values. So y would be equal to 2 times of x. So let me also print out y. So I also have my y values ready. Now it's time to finally make the line plot. So to make a line plot, all we have to do is type in plt.plot. So this plt is basically the alias for this pyplot submodule. Now, whatever plots you're making, that all of them you'll be making with this pyplot submodule. And to make a line plot, you will be using this plot method from the plt submodule. So you'll just put in this round braces over here, and then you'll pass in the x and y values as the initial parameters. So you'll type in x, comma, y over here. After that, just type in plt.show, click on run, and then you successfully have created your first visualization. Now, isn't this a beautiful line plot? So over here, what we basically have is the x-axis. This is the y-axis, right? So when you have the x value to be equal to 2, the y value is 4. When you have the x value to be equal to 4, the y value is 8. And that is what this line plot is telling you. Now, wouldn't this be even better if we add title, X label and a Y label to this? So let's go ahead and do that. So let me add the title. So to add the title, you have to type in plt.title. And let's say the title which I'll be giving this is line plot. Now let me give it the x-axis label. So this would be plt.xlabel, and I'll just simply put in x-axis over here. Now let me also put in the y label. So I'll type in plt.ylabel, and inside this I'll type in y-axis. Right, so we have added the title, we have added the x-axis, and we have also added the y-axis. Now let's say I want to change the color of this line. So I don't really like blue, maybe I want green color or red color. So how do I do it? So over here, so I would have to go inside this main function, which is plt.plot, and I will use the color attribute and I will set the color. So I want this to be green, so I'll just type in green over here, right? So now I have changed this color to green. Similarly, if I want this to be orange, I can just type in orange over here and the color becomes orange. Now I can also play with the line width and the line style of it. So I'll just type in line width over here and let me set it to be equal to, let's say, 2. Let me click on run. So let me remove this underscore over here. Right, so I have increased the line width. So to make it more obvious, let me make it 5 over here. Right, so this has become thicker. So you can give it whatever value you desire. I'll give in 50. Right now this has become quite thick over here. So let me change it back to 2. 2 seems quite good for this. Now I can also change the line style of this. So I'll type in line style and I'll set the line style to be equal to colon. So when you put in colon, this is what you get, right? So you have a dashed line over here. So this is how you can basically create a line plot, right? So first you will type in plt.plot and then you will give in the x values and the y values. Now after that, if you want to describe the plot more, you can add the title, you can add the x label and also the y label. So let's say if you also want to add a grid to this. So all you have to do is set in plt.grid. So this has to be small g over here and you will just type in true inside this, right? So you have also added a grid to this. So this is how you can add a line plot. Now let's say I want to add 2 lines inside this one single plot. So what I'll do is I will actually add one more y value. So my y1 is 2x over here. Similarly, I'll also create y2. So I'll set y2 to be equal to 3x. So let me print out y1 as well as y2. Right, so this is y1 and y2. So I will be making 2 plots over here. So first is with respect to y1 and x. Next would be with respect to y2 and x. Right, so now we have 2 lines over here to distinguish them. Let me give it a different color over here. Let me change this to, let's say, back to blue again. Right, so this is the line which denotes y is equal to 3x and this is the line which denotes y is equal to 2x. So this was a line plot. Now let's go ahead and create a bar plot. So I'll just give in a comment over here, bar plot. Now to create this bar plot, I would need a dictionary first. So let me again name this dictionary to be student over here. And I'll have some names of students and the marks of the students. So let's say the first student is Sam again, and he has scored 30. Then we've got Bob, who has scored 50. And finally, we've got Julia, who has scored 70. So we have created this dictionary over here. Once this dictionary is done, I'd have to extract the keys and store it into a separate variable and extract the values and store it into a separate variable. So I'll take this new variable called as names and I will extract only the keys of it. Now, once I do this, I would need the list of the keys because the plt.bar function only takes a list of values. I'll cut this and I'm pasting this inside this. Similarly, also extract the values. So I'll be storing that in the marks object. Again, let me do the same thing. So this will be student.values. So let me print out names and marks over here first. Names, and then I've got marks. So I have extracted the names and then I've also extracted the marks. Now to make a bar plot, I just have to type in plt.bar. So first I would have to give in the categorical values which are stored in names. And then I'd have to give in the corresponding numerical values with respect to those categorical values which are stored in marks. Let me also put in plt.show over here. Right, so this is my bar plot. So this graph basically tells me that there are 3 students. First is Sam, who has scored 30 marks. Then there is Bob, who has scored 70 marks. And then there's Julia, who has scored 70 marks. Now, again, if I want to change the color of this bar, all I have to do is use this color attribute and give it a different color. So let's say I want to give it yellow color. So I'll set yellow over here. Right, so I have changed the color. Now again, if I want to give the x-axis label, y-axis label, and the title, it does the same process again. So I'll type in plt.title over here, and I give the title as marks of students. After that, I'll set in the x-axis label, so plt.x label, and that would be equal to names of students, and then plt dot y label, which would be equal to just marks. Right, so marks of students is the title, marks is the y-axis label, and names of students is the x-axis label. Again, if I want to add a grid, it will be plt dot grid, and I'd have to just set in true over here. Right, so this is my bar plot. There is also something known as a horizontal bar plot. So over here we have these bars stacked vertically, but instead, if you want to see these bars horizontally, then we have this bar h function from the pyplot module. So the only difference which we'd have to do is, instead of plt.bar, we just have to put in plt.bar h. And when you do this, this is what you get. So initially these bars were stacked vertically. Now when you use bar h, these bars are stacked horizontally. Now let's go ahead and create a scatter plot. Let me add the comment over here. All right. So first I'll go ahead and create 2 lists over here. So I'll name the first list as X again, and I'll give in a bunch of random values over here. So I'll take in, let's say, 6 random values. So 1, 2, 3, 4, 5, and 6. Now similarly, I'll take another list. I'll name it to be Y1. Now you have to keep in mind that you take the same number of values in X and Y, because a scatter plot, it basically gives you a point for a specific position of X and Y coordinates. All right. So again, I'll give in some random 6 values. So 9, 1, 2, 6, and 4, and 9 again. So we've got the X and Y values ready. Now to make a scatter plot, all you have to do is just type in plt.scatter and then pass in the X and the Y values. And this is what you have. Let me also add the grid. So plt.grid, I'll make it to be true. Right, so this is what you have. So this is the first point where the X coordinate is 1 and the Y coordinate is 4. Right, so this is the point which it is denoting. And then we've got 3, 2. So 3, 2 would be this point. Then we've got 4, 9. So 4, 9 would be this point, right? So this is how a scatter plot looks like. Now let's say if you want to depict 2 different point themes on the same scatter plot, then all you have to do is create a new list. So I'll name this to be y1. I'll set it to be y1 over here. Let me again create a new list, which is y2. Let me give in a bunch of random values again. So 4, 7, 8, 1, 2, 6, right? So I've got my bunch of 6 values over here. Let me create another scatter plot over here. So this time it'll be with respect to x and y2, and I will give it a different color. So the color would be red. Right, so I have added 2 different theme points on the same graph over here. Now let's head on to the next plotting, which is a histogram. So histogram basically helps us to understand the distribution of a continuous column. So for this, we'll be actually loading the iris dataset again and understanding the distribution of some of the continuous columns of that dataset. So again, I'll load up the dataset. So I will type in pd.readcsv. And now I'll give in the name of the file, which is iris.csv. And I'll store this in iris again. All right, so let me have a glance at the head of this again. So iris.head. Right, so this is our data set. Now I want to understand the distribution of this sepal length column. So for that, what I'll do is plt dot, to make a histogram, we've got this hist function. And inside this, I'll just give in the name of the column. So iris, and I'll give in the name of the column, which is sepal length. And then I'll just put in plt dot show. So this is the histogram, and this shows us the distribution of the sepal length column. Now to increase the distribution of these bins over here, we've got the bins attribute. So I'll just type in bins. So let's say I want 20 bins. So I'll just type in bins. So I'll just set the bins value to be equal to 20. So the inference which we can draw from this plot is, so let's say if we take this particular bin over here, then this tells us that there are around 16 records where the sepal length of the flower is exactly around 5. Then we've got this over here. So this bin tells us that there are again around 16 records where the sepal length is 6.5. And if we take this bin over here, so there are very few records. So this would be, let's say there's just one record where the sepal length is somewhere between 7.5 and 8. So again, if we take this bin, so there would be around 4 records, or there are just 4 flowers whose sepal length is 4.5. So this is the sort of inference which we can draw from a histogram. And the basic difference between a histogram and a bar plot is, so a bar plot is used to understand the distribution of a categorical variable, while a histogram is used to understand the distribution of a continuous variable. Now similarly, if I want to understand the distribution of, let's say, petal width, so I'll change this over here. And I'll just put in petal width. Right, so this is the distribution of petal width. So there are around 34 records whose petal width would be somewhere around 0.2 or 0.3. So those constitute a lot of flowers, right? And if we take this bin over here, so there would be just one record, or there's just one flower where the petal width is 0.5. And this seems to be the maximum petal width, which is around 2.5. So the maximum petal width of 2.5, there are around 5 records. Right, now let's again understand the distribution of sepal width. So I'll change this and I'll just put in sepal over here. Right, so we have a big peak over here. So there are 25 records where the sepal width is 3. And there is just one record whose sepal width would be around 4.3 or 4.4. Right, so this is histogram. So now we'll go ahead and make some box plots. So box plots are used to understand the distribution of how does one continuous variable change with respect to a categorical value. And again, we'll be building box plots on this iris dataset. So I'll type in iris.boxplot. And this basically has 2 parameters. So the first parameter is the column where we'll assign the y values, or the continuous value. And the continuous value which I'd want to give in is sepal length over here. So I'll type in sepal length. And then I'll map the categorical value onto the x-axis. So for this, I've got the by attribute, and we've only got one categorical variable over here, right? So the species column is the only categorical variable which you've got. So I'll type in species over here. I'll hit on run, and this is the box plot which we've get. So what you see over here, so this line which you see in the middle of this box, this is known as the median line. This is the 25 percentile line, and this is the 75 percentile line. Let's just focus on this median line over here. So this tells us that if the species of the flower is setosa, then the median sepal length of the flower would be around 5. And again, let's take this box over here. So if the species of the flower is versicolor, then the median sepal length would be around 5.9. And let's take this. So if the species of the flower is virginica, then the median sepal length over here would be 6.5. So this is the inference which you can draw from a box plot. Now, similarly, if I want to understand how does petal width vary with species, let me just put in petal width over here. Right, so again, we have 3 boxes over here, 1 box each for the different species of the iris flower. So over here, it seems that the median line would be somewhere over here. So if the species of the flower is setosa, then the median petal width would be around 0.3 or 0.4. Then we've got versicolor over here. So if the species of the flower is versicolor, then the median petal width would be 1.2. So the basic inference is virginica over here would have the maximum petal width and setosa would have the minimum petal width. So that was the same case which we saw with sepal length as well. So virginica had the maximum sepal length and setosa had the minimum sepal length. If we want to make this plot even more beautiful, we can use the Seaborn library. So let me just import the Seaborn library. I'll type in import Seaborn as SNS. Then we've got the box plot method from this. So sns.boxplot. Now what I'll do is I have already loaded this iris dataset. So onto the x-axis, I'll be mapping the species column. So iris, and I'll type in species, and onto the y-axis, I will basically map the sepal length column. So again, iris. So the name of the column is sepal length. Alright, so this is a much more beautiful plot when compared to this. So again, the inference is pretty much the same. Alright, so virginica over here would have the maximum sepal length, or the median sepal length would be maximum for virginica, and the median sepal length would be minimum for setosa. So these are the inferences with respect to box plot. Now we'll go ahead and work with the final plot with respect to visualization, which would be a pie chart. So before we make this pie chart, we have to create 2 lists over here. So I'll create first list with the name fruits, and I'll just add some names of fruits. So the first fruit is apple, second fruit is mango, then we've got orange, and then we've got banana over here. So I've made the first list, and then I will give in the cost of fruits over here. So I'll just give in some random values. So 76, 45, 90, and let's say I'll give in 85 as well. Right, so I've got the fruits list ready, and I've also got the cost list ready. Now all I have to do is map these two into a pie chart. So I'll type in plt.py, and inside this I will first map the numerical values. So I'll type in cost, and then I'll map the labels. So we've got the labels attribute over here, and for this labels attribute, I will map this list to the labels attribute. So I'm mapping fruits onto labels over here. Again, I'll just click on run. So beneath this, I'll put in plt.show. Right, so this is my pie chart over here. So this basically tells us that the maximum distribution or the maximum percentage is mostly of orange and banana. And that is actually true. So orange, if we see, the value is 90, and banana, if we see, the value is 85. If you want the actual percentage, we have something known as the auto PCT attribute. So let me add in the auto PCT attribute over here, and I'll put in single quotes. I'll put in a percentage symbol, and then I'll type 0.2. I'll type in F, and then I'll give in 2 percentage symbols over here. Right, so we've got the percentage values over here. Now what does this exactly mean? So this 0.2 basically denotes the decimal value. So if I put in 2 over here, then this will show 2 decimal values. Let's see if I just put in 1 over here, then you've got 1 decimal value over here, right? Now I can also add a shadow to this. So I'll just put in shadow equals true. And this is my pie chart over here. So this shows us that the maximum percentage of the fruits belongs to orange. We've got 30.4%, and then we've got banana 28.7, followed by apple, and then the least is mango. Now let's see if I want to increase the size of this plot. So we have something known as plt.figure. I'll type in plt.figure, and inside this we've got the attribute fig size. So I'll give in the value 6,6 over here, right? So I have increased the size of this. Now similarly, let's say instead of 6,6 I put in 10,10, then this would be enlarged even more, right? So this is our final pie plot. Right, so guys, this brings us to the end of the visualization module. So this brings us to the end of this Python tutorial. I hope that you've comprehensively learned all of the concepts. So thank you and happy learning.